Hello, I'm glad to present our CHI 2024 paper, Designing Scaffolding Strategies for Conversational Agents in Dialogue Tasks of Neurocognitive Disorder Screening. Neurocognitive disorders, such as Alzheimer's disease, are common among older adults. If you recall the film The Father, you can understand that NCDs impair the quality of life of patients and their families. Meanwhile, it increases the burden on caregivers and healthcare systems, imposing a financial strain on society. However, NCD-associated symptoms can be managed through early diagnosis and preventive interventions, which requires a scalable approach for routine screening of cognitive impairment. Currently, NCD screening and diagnostic tests, such as MoCA, are primarily administered in person by clinical professionals. Unfortunately, the scalability of human-administered approaches is limited by reduced mobility of some older adults, clinical shortages, and inter-rater variability. Previous studies suggested that having an automatic conversational agent chat with users regularly could be an affordable means to capture data for NCD screening. While existing NCD screening administered by CA systems typically begins with a simple dialogue strategy, communicating with people who may experience reduced cognitive abilities often requires special conversational skills, such as back-channeling. However, there are many other more complex conversational skills and techniques that humans adopt in communication with NCD patients. Among them, scaffolding, a process that keeps NCD patients engaged and facilitates activity understanding, is considered critical to support NCD patients' daily activities through dialogues. Compared to learning decision-making domains, designing CA's scaffolding strategies for dialogue tasks of NCD screening is still underexplored and bears unique challenges. First, the target users are individuals with potential NCDs, suggesting that the CA design should be rooted in scaffolding theories and practices for these people particularly. Second, the objective of the CA is to facilitate the user's task understanding during the screening and their exhibition of current cognitive abilities, rather than providing direct answers or teaching them new knowledge. This raises two research questions. RQ1. How can a conversational agent for NCD screening be designed to exercise clinical professional scaffolding strategies? And RQ2. What are the effects of the conversational agent's scaffolding strategies on the user's task understanding during the NCD screening? To address the research questions, we proposed a design process for the CA that administered the dialogue task for NCD screening. To identify clinicians' scaffolding strategies, we first analyzed the conversation recordings between clinicians and subjects during the dialogue task of NCD screening, the GSDT. We chose the Hong Kong grocery shopping dialogue task, because this is representative of tests that encompass multiple cognitive functions, involve dialogue, and are administered in person by a clinical professional. In the GSDT, the subject is requested to purchase ingredients for a dish and narrate the process with reference to the floor plan of a grocery store. We digitalized the test with a 3D token, the figurine in the screenshot, representing the subject's location in the grocery store. First, subjects are presented with an image of a dish and are assigned the task of identifying its ingredients. Subsequently, the subject verbally articulates the step-by-step process of purchasing the identified ingredients, simulating an experience in a physical grocery store using a map or floor plan. The tester manipulates a token representing the subject's position on the map, while the subject provides instructions on its movement. The map may feature obstacles like walls or shelves, prompting the subject to devise feasible paths for accessing all the necessary ingredients. Our content analysis covered video recordings of 12 subjects performing the GSDT with human testers in real clinical settings. Based on the theory of scaffolding for individuals with NCDs, we identified 5 scaffolding strategies at 3 levels applied by professional clinicians. We will show some examples later. We extracted 2 design guidelines from the content analysis. First, adjust scaffolding according to the zone of proximal development. The ZPD means that the person can do the task with certain support. Between the ORZ where the person cannot do it even with other support and the ZAD where the person can do it independently without support. Based on the ZPD theory, we categorized 4 types of subject responses. The testers assessed the subject's ZPD status according to the response type and selected the appropriate scaffolding strategy. Second, follow the 3-level scaffolding framework we proposed for the CA. Generally, the GSDT consists of many activities. Such as, the subject needs to name the needed ingredient, locate the shelf, move the token to the shelf, and purchase the ingredient. This process could be repeated to purchase all the ingredients. If the user's response provides enough information to complete the activity, the CA uses activity scaffolding to transition to the next activity. Or, the CA applies action scaffolding to prompt for further information to complete the activity. When the subject continuously responds mistakenly or signals difficulties, repair scaffolding can be applied. Let's watch a demo of the activity scaffolding.
買番茄
This is the correct answer for the activity of naming the ingredient.
好嘅，邊度可以搵到呢個呢？
The CA employs the activity scaffolding to transition to the next activity, locating the shelf.
咪蔬菜水果嗰度啦。
點樣行過去呢？
The activity scaffolding again to transition to the next activity, moving the token. Then, the action scaffolding.
轉左
好嘅，而家點樣啊？
The participant responds with a correct answer but the activity has not been finished. The CA turns the token accordingly and employs the action scaffolding to prompt for the next step.
向前行
OK，
And the repair scaffolding.
我而家停咯。
好嘅，
買番茄
要面對住個貨架先可以買到嘢㗎喎。
咁啊轉左
而家要向邊邊轉呢？
The participant did not know the rule of facing the shelf to buy things. Instead of helping the participant turn the token directly, the CA employs the repair scaffolding by reminding about the rule. Based on the system we built, we conducted a Wizard of Oz study to complete the GSDT administered by our CA. Wizard A applied our framework to scaffold the user and Wizard B controlled the token's movement. The goal of this study was to check the appropriateness of the CA's scaffolding and to explore its effects on the user's understanding of the dialogue task. Wizard A used this back-end interface to manage the framework. Once the user input is categorized, all the available scaffolding strategies will be listed in the 4th column based on the framework. When the framework provided multiple available strategies, ChatGPT would recommend one from them. We invited 3 clinical experts to watch the replay of the study and review each strategy used by the CA. Around 89% which were considered appropriate. ChatGPT also showed the viability of recommending appropriate scaffolding strategies. In response to RQ1, which focuses on how to design a CA that can implement scaffolding strategies used by clinical professionals, we presented a design process for the CA that incorporates the scaffolding strategies derived from the earlier content analysis. The results suggest that the CA, developed through the proposed process, effectively exercises the scaffolding strategies employed by clinical professionals, thereby addressing RQ1. Participants also subjectively perceived the helpfulness of the CA's scaffolding in task understanding and evaluated the CA with generally good usability. The result answered RQ2 about what the effects of the CA's scaffolding were on participants' task understanding from a subjective perspective. To address RQ2 objectively, we conducted an analysis of the conversation log regarding the CA's usage of scaffolding for the participants completing each scorable activity throughout the study. We identified a decline in scaffolding use aligning with the pattern of the human tester's scaffolding use. This implies that the CA's scaffolding possibly facilitated participants' comprehension of the task and promoted their independence, thus addressing RQ2. The CA's scaffolding strategies may be generalized in other NCD screening tests. Scaffolding for NCD patients is usually deployed verbally and many cognitive tests contain dialogue parts. For example, in the cookie picture description task from Dementia Bank, the CA may scaffold at the activity level by asking, "Can you describe everything happening in this picture?" Or scaffold at the action level by asking, "What happened next?" or scaffold at the repair level by encouraging the user to take one more look at the picture. To summarize, our key contributions are threefold. First, we propose a process for designing the CA's scaffolding strategies for NCD screening. Second, we explore the effects of the CA's scaffolding on the task understanding of the user during NCD screening through a user study. Third, we propose implications for the future design of CAs that enable scaffolding for scalable NCD screening. Please check our paper for the details of design implications. Thanks for listening.